Hi all, and welcome to part 3 of the 3 Degree of Freedom motion platform simulator build. In this video we're going to talk about the tools we need to get this build done. And I'm going to start with the tools we're going to need for all of our wiring. I've used a combination of wiring and joiners and soldering to put my rig together, which will work perfectly well in most applications of this type. I went to good old J-Car here in Australia. You can buy all sorts of kits and stuff from them. That's where I got all my comm wire. You can see these are all just female to female comm wire. I bought a bunch of male to female comm wire. I've used a combination of all of those, mainly for those connections to our IBT, to our shared 5-volt power source from our Uno Arduino R3 board. You'll need a little heat shrink kit because you will do some soldering and some joining. So you'll need some different grades of heat shrink to cover you for that. You can buy those again from J-Car. An automotive terminal kit is very handy. I've used a lot of that for this build. Also, you can get that from J-Car or Super Cheap or wherever you can get terminals. With this stuff, the important thing with this is, and it works perfectly well, and you can do a combination of this and soldering, but you do need to make sure you've got a good tool like these crimpers, and these are only $10 from Autobarn to crimp those terminals. If you've got a good crimping tool, you can use those, no problem. Now, when it comes to stripping your wire, you can do it with your teeth if you want to, but I would highly recommend going out and getting a set of fast strippers like these guys. Adjustable, easy, clean, and, again, about 10 bucks from Bunnings. Right, you'll need a pair of parrot nose cutters for cutting your wire. All my motors, the wiring that runs to all my motors was in a dual core setup like this, okay? It's 14 gauge wire, which is heavy enough for what I need to supply to my motors, the 12 volts. I've used some single core wire in different applications. I had some of this multi-core wire lying around that I used to connect to my rear pentometer. But you don't need to do that. My front pentometers, motors are all just individual wires. This sort of wiring here, which was left over from an automotive wiring kit. I rewired my classic car last year from bumper to bumper. Bought a 12 circuit wiring kit from American Auto Wire and rewired the whole car. And I had quite a bit of wire left over, and I've utilised that. You can buy this stuff for kits from J-Car. This would do a lot of wiring if you wanted to hard solder onto your Arduino, for example, or into your IBTs. You don't really need to, but if you wanted to, this is the sort of wiring kit stuff that you need. This is reminiscent of a Tokyo subway map, but it works. It's a little bit untidy at the moment. A lot of this stuff I will probably tidy up with the zip ties. This lid actually closes inside. So all of my IBT2s, the Arduino Uno R3 board, the little breadboard here that takes multiple power, that all closes inside itself. And then the fan that's installed here, it's the 12-volt fan that runs off the 12-volt power supplies. It pulls the air through to try and keep everything a little bit cooler. So you can see here where I've used the combo of the comm wires. Comm wires, for example, there on the IBT2 H bridges, going back to the Uno Arduino. But then the wires, the 12 volts I've got coming off my power supplies, that's a heavier wire. This is leftover stuff from the automotive wire I was talking about, but there you go, there's a 16 gauge. So basically I've got 16 gauge power running to my IBT2s from the 12 volt power supplies. You do want a reasonably heavy wire into your IBT2s. The red and white there, that's the wire I was showing, that double core. That goes to all my motors. And that is 14 gauge. It doesn't get hot. It does as it should. That's more of that automotive wire I had left over from my build that goes for my pentometers, which goes onto the Uno on your AO, A1 and A2s there. So that's just they're just three wires I've wound together. You can see there over the frame, I've probably gone a bit over the top there with the hot glue gun, but I didn't want it to go anywhere, and I've also put a bit of hot glue on the wires to keep them all together. Stuff, and I've just joined them all, like I say, with those automotive joiners, crimped properly, perfectly fine. During all the testing that's been done while this has all been running, I've been checking all of those wires, and none of them get hot. You know, if I'm running the rig for a couple of hours, just with it in sine wave or whatever through SMC through utilities, the wiring is not getting hot. That was just a very quick overview to give you an idea of the different applications for the different gauge wiring that you're going to need. So just keeping in mind that those comm wires, you know, they are very small, but they're only running 5 volt. The IBT2 H bridges here, they get their power from the 5 volt supply that comes from your USB connection from your computer into your Arduino Uno R3 board. They're only needing to take 5 volt, any of those. The bigger voltage is at the back end after our chips here have done their job on the IBT2s. Then you need the heavier wire going in, so then you've got you've got a nice 12 volt going in, and then some decent wire going out. All of these connections here that go into the IBT2, they've all been soldered. We'll talk about that in a minute, and we might go to that next day. Let's talk about what we need now as far as our soldering goes. You're not really going to be able to get away with not using a soldering iron of some description. Now, I've got a fairly fancy soldering iron, just a temperature control soldering iron, really. It's not that fancy, with a few different tips that I can interchange in the actual iron itself. You'll need a fine tip for doing most of this soldering for this work, but you don't need that sort of full kit. You can just buy these single heat ones. They don't work quite as well because they cycle on and off a lot more. This one happens to have a little turbo button which you can use up to 20 seconds, which will boost some more heat into it. So you'll need a soldering iron. Okay, you'll need some solder, a few containers of solder, just a lead-free solder will get the job done. I can't really see how you can avoid buying a soldering iron, because you need to be able to solder onto your potentiometers, for example. I wouldn't recommend trying to wind them around the poles and try and keep them on with a bit of cellophane tape. And I wouldn't recommend that for joining wires either. Though I have seen it, I don't think it works that well. A little third hand here. I've had this one for years. It's falling apart a bit, but a third hand, they're cheap and they're extremely handy for soldering, holding 2 wires in place while you solder them. So definitely get one of those, or you'll be pulling your hair out. And the other thing I'd highly recommend, because you will need this, is a little battery. Just a little 12 volt battery. That's a little rechargeable 12 volt battery I also bought from JK. I think that was about 40 bucks. That's been extremely handy for connecting to my motors when I need to move the shafts, when I need to move levers into the right positions as they move around, and just be doing a bit of general testing. Definitely handy to have a little 12 volt battery on hand. You don't need a big car battery, especially if you're going to buy those power supplies like I have, which are actually going to run your motors. But initially, when you're trying to move your motors into position, move the shafts into their positions where they needed to be, it's going to be really handy to have those. I could not move those shafts by hand. They're just too hard to move. I needed to connect them to the battery to move them. I would highly recommend getting yourself a battery. Very, very handy to have a multimeter, guys. Once again, this was a cheap, like $19 multimeter I think I got from JCar. It was on special. I've used this for a whole bunch of stuff. It works perfectly fine. It's got continuity with alarm, etc. Get yourself a cheap multimeter. The other very important piece of kit you're going to need is a emergency stop button on your rig. Highly recommend this. Your rig may get out of control in some situations with some of your gaming, like if you roll the car, etc., and suddenly your rig goes absolutely spastic. You need to cut the power to your motors, or anything could happen. So I think an emergency stop button is absolutely essential. This was not a cheap one. This was 120 bucks. It's a very high quality emergency stop button. I bought this one originally from JCar with $16. Now this would work perfectly fine as well, but this would need to be modified a little bit. I was going to have to modify this anyway. You'd have to buy a hobby box to put this in before you could use it anyway. But because I think that is a really important part of the build, I would not muck around and buy anything too cheap. I want something that's going to work for a long time and I know is going to work. And we'll be talking about how this is going to be installed during the build. That's definitely another one in the electronics department that you need to get for yourself. You will need some implements for measuring. You will definitely need a set of squares. Okay, get yourself a set of squares. You will need a protractor, just a basic protractor. for some angle finding. We'll go into what that used for. You can get a larger one. Once again, another Aldi, good, different angle finder that I bought, which I use in a few different applications. Get yourself a spirit level. Okay, just a cheap spirit level will do most of the stuff you need, and absolutely get yourself a tape measure. Okay, an 8-meter tape measure, probably a sensible tape measure to have if you don't have one. Please get these items for measuring and squaring before we cut and weld. You're going to need some clamping devices for when you're welding, for when you're putting your frame together, so then you're holding stuff straight, you're holding stuff square, and then when you weld, things don't move. Because when you weld and when you start applying some serious heat to things, your metal will move and you will end up with stuff out of square. Okay, you need to use a combination of squaring magnets like these guys. These can be got in all types of shape and sizes. You know, you can get little ones. I've got a range of different magnetic devices for when I weld, but you want a decent size set, so the larger ones, you need to grab those, and you need clamping, okay? And just some basic F clamps will do you perfectly fine to work in conjunction with your magnetic square finders, okay? Or some different vice clamps are also very handy as well. All of these things can be found very cheap on eBay. Okay, super cheap. I think I bought a 4-pack of those, and they were like 26 bucks for 4 of them. You can get 4 packs of these for like the same sort of money. Like, they're cheap. Okay, they're cheap. Get a couple of longer ones. They're 200s, they're 150 millimeters. Get 150 millimeter and 200 millimeter F clamps, 2 of each. That's all you'll need for this project, and for most of your projects going forward. Depends on what you're going to become insane about building. All right. Get yourself some clamps for holding together your metal pieces when you are welding. If you don't already have them, guys, you're going to need some screwdrivers, okay? You're going to need a couple of different sizes in Phillips head, small and a medium. And you're going to need a small flathead screwdriver. That's for our IBT2 terminals here. Okay, it needs to be small enough to go in those. It's a small one. You will need a couple of different size flat screwdrivers and a couple of different size Phillips head screwdrivers. Get some of those, you will be needing those. You're going to need a way to mark your metal after you've measured it, so you know where to cut it, okay? So you need to get yourself a range of markers. What I find are the most effective markers out of all of these are the scriber here, okay, which scribes into your metal. A good Sharpie, just a good black Sharpie with a good Sharpie tip, okay? So then you're accurate in your measurements. Here's something I built in high school, which is very handy, and this can measure in lines and cut them in. You can buy something similar to this in a hardware store if you want to buy one of those. Really good for doing long lengths of measuring, where you've got a long line and you want to repeat it over and over again. You can buy something like that that's adjustable, and then it marks in your mark. But we'll talk all about that when we're doing the build. I'll show you how to use these things. A Sharpie, a scriber, and maybe a metal marking pencil. That'll get you out of trouble for now. You don't really need this. That's just me showing off. Please get those things to make your life easier to mark things, so then when you mark them and go to cut them, you're not pulling your hair out going, where was that mark? Where was that mark? Where was that mark? ADHD, ADHD, ADHD. Okay, you're going to need a decent set of leather gloves for when you're welding and angle grinding. Riggers gloves, they're called. And I just buy these from Bunnings. They're pretty cheap. They're about 12 bucks for a set. You will go through a couple of sets. So buy a couple of pairs of those in whatever size you need. Get yourself a couple of pairs of those. Some extremely important bits of kit you're going to need to accomplish this build is a drill. You only need a corded drill. If you've got enough money and you want to go out and buy a cordless drill, that's fine, but you will not need to buy one of those. And I can tell you now, corded drill's got more power than what a battery drill has got, especially if you buy something like this guy. Now, this cost me about $29 from Bunnings. Just a Chinese brand drill, but it's a heavy duty drill, comes with a stabilizer handle. It's a 13mm chuck, so it'll take decent sized drill bits. We're talking here, you want to get something in the same range as this, where you've got 810 watt drill. You're going to be drilling some reasonably thick metal, up to 8mm in thickness. You need a decent drill. That's going to help you accomplish that without pulling your hair out all day. You also need to buy a decent angle grinder, okay? Once again, just get a corded angle grinder. I've had this angle grinder for years. It's just a Zito. It cost me like $49. It's a 2100 watt 5-inch or 125 millimeter angle grinder. You're going to use, you'll be doing a lot of cutting, a lot of shaping. So get a decent angle grinder. Don't do what I've done and take the bloody guard off it. Well, I needed to take the guard off it for this wire brush. And you won't necessarily have to buy this wire brush, but you will need some other grinding discs and cut-off discs, etc. And I'm going to show those now. But they're 2 bits of kit that you need to get yourself to get this build done. Let's talk about some of the stuff we need to get for our angle grinder and our drill for cleaning and cutting of our metals. Okay, so prep is very important with metalwork, particularly with welding. We need a clean surface to weld on. We don't need to use products like brake clean or carby cleaner or acetone or anything like that. We don't want to be creating fumes from those types of products. We just need a clean surface that we either grind with a grinder lightly or a wire brush, either a hand brush or these ones that go into a drill. Okay, or you saw the one that was on my angle grinder. That's even a heavier wire brush for really cleaning stuff off. On our base plate, okay, on all that flat steel, if we want to paint that, we have to get rid of all that milling scale. This grey sort of colour stuff, that's called milling scale. That's what comes out of the hot press when the metal is made and formed. And if we don't remove that before we paint it, it eventually breaks down and flakes off, and it'll cause all your paint to flake off. So that stuff needs to be removed mechanically. I've got some acid baths here at my house, and I acid bath all of my metal, but that's a fairly complicated process, and you're not going to want to set that up. So get yourself one of these flap discs, okay, that go on your angle grinder. These are the most effective thing for removing mill scale, paint, anything like that, primer on some of your box steel. That stuff gets it off very quickly, and it does big areas very quickly. Get 5 or 6 of those to do all your metal prepping before you paint and for cleaning before you weld. Like I said, this is a little, I think that's about 125 millimeters or something like that, little wire brush that goes in a drill. There's a cup brush that goes in a drill. Like I say, you need probably half a dozen grinding discs, and you need probably 10 cut-off discs for your angle grinder. Get those, and you're on your way to simulator heaven. Now let's talk about some of the tooling we're going to need for our drill. Remember when I said not to have a heart attack when I was talking about what you're going to have to spend? You're going to need to buy a few tools that will be with you throughout your life, tools that will cause you to become addicted to working with metal, with timbers, tools that could lead to a divorce, but it was worth every penny because it's tools, tools, tools. This is a carbide cutting, metal cutting tool set, okay? I think this cost me about 69 bucks. Now, you don't have to buy a whole set if you don't want to. You will need either a 16 millimeter metal cutting saw. This is carbide. You can get them in like this kit here, which is it's like a bimetal sort of slash timber kit. You can buy those cheap. That was an Aldi kit. Work zone, good, different. But yes, that cost me about $19 on special at Aldi. You can get those kits. You can spend a bit more, get this kit. You could buy individuals. You could buy a whole set of drill bits. I would highly recommend those even if you don't have them. So they're just a whole set of drill bits that go up to 13 millimeters, and that will fit in any 13 millimeter chuck drill you get. I don't know if I mentioned that before, but please, well, if you get a big drill like that one I showed you, it's going to have a 13 millimeter chuck anyway. You want a 13 millimeter chuck. Now, the 16 millimeter is for drilling our shaft levers, okay? The levers that go on our shaft that connect to our push rods that move our frame around, our pitch, our roll, our traction loss. That shaft needs a 16 millimeter hole in those levers. So you will need a 16 millimeter drill bit of some description. If you don't want to spend all the money and get a full carbide set or even a bimetal hole saw set, you can get 16 millimeter drill bits with a 13 millimeter shank. So the drill bit itself will be 16 millimeters in diameter, but the shank that goes into your chuck and your drill has been machined down to 13 millimeters. You could just buy one of those if you really are only wanting to do this build and that's it, and you wanted to spend the least amount of money as possible. Just buy one of those, okay, to get you out of trouble. But you will also need to buy a 44 millimeter or 45 millimeter hole saw, timber hole saw. You can get away with timber. You are going to need that for drilling your Merbow timber for your motor shaft to be able to come through here, that hole there that our motor shaft is coming through from our motor, that needs to be a minimum of 44 millimeters. So you will need a hole saw, because that's going to be one hell of a hole to try and cut without a hole saw. You can buy single hole saws if that's all you want, or you can get a cheap kit off eBay. You could buy a cheap kit off eBay for probably about $25 or something. Probably do most of the stuff you need to do. I've had this kit for a long time and I've done a lot of stuff with it. Guys, you're going to need some basic hand tools for doing up nuts and bolts. You know, you can get yourself a couple of different size shifting spanners. They'll do most of what you need to do in this build. Or get yourself like a cheap socket set. Okay, this is an old king chrome set I've had for years and years. I think I got this back my 25th birthday. I've had it for a long time and it's gone the distance. King chrome stuff is okay. You know, if you want to buy a full set of sockets, or even just medium range sockets, you can get a set of those. You're going to need a 5mm Allen key hex head drive. But at the very least, you're going to need a shifting spanner, and I'd get like a 10-inch like this guy. And what's this? A little 150mm SID chrome I've got there. You'll use those. And they'll get most of the stuff done, because really all you're using those for in this build is just for doing up all of your connecting rods here. Just for these bolts on your tie rod connecting. And of course, our motor bolts. Shifting spanners will do the job. Another important piece of kit for fastening all of our tech screws that we are using on this build. An impact drive, okay? This is a very cheap Azito impact drive from Bunnings. The dearest part of these are the batteries. I think the skin, what they call the skin without the battery, I think can be had for about 49 bucks. This is not brushless. If you want to spend a bit more, you get a brushless. This is not a brushless. I've had this Azito impact drive for probably about 3 years and I use it to death and it still works. You'll just need a battery to go with it and a battery charger. I think you can buy these impact drive kits with a charger for about $79. Get one of those. That will fasten all of your tech screws into your metal, okay? You really need one of those to make your life easier. You probably could do it with the drill, but they do not work as well as an impact drive. Then you need to get yourself a little basic tooling kit for an impact drive, like this one here. This happens to be a Milwaukee. Okay, it's called a Milwaukee Shockwave, but you can get multiple versions of these. You can buy cheap ones on eBay. You just need to make sure it's got an 8mm socket head, okay, to drive those tech screws. Doesn't matter what it's got, as long as it's got an 8mm drive, okay, that drives those tech screws, okay? Or even if you just want to buy one of those, just buy one of those. Don't buy the whole kit. But the kits are pretty handy. But so you want an 8mm or, I believe, 5/16. Yeah, 8mm or 5/16 hex head drive and an impact drive. Get one of those. Highly recommend a face shield for all your angle grinding. And grinding, okay? You can get safety glasses, but I've had metal shards in my eyes wearing safety glasses. And believe me, it's not very pleasant when you've got to go and have that taken out at the hospital. And then for 2 weeks afterwards, they have to grind your eyeball to get rid of the rust ring. You should wear a full mask. That is going to give you the best protection from anything ending up in your eyes. Face shield for grinding, a set of earmuffs to protect your ears. Okay, you can get these face shields with built-in earmuffs. I'd get those. These can be a little bit awkward to use when you're using these face shields. So maybe go for the face shield with the earmuffs. An invaluable tool in any workshop, and for you in this build, is a vise. This is a 125mm vise. This just happens to be set up on an old rotor I had lying around. You can buy them so then they can clamp to a table, or you need to bolt them or tech screw them or timber screw them into a table. A table, you'll need some sort of table to run a vise on, but they really are invaluable for holding metal, etc. when you're welding, or anything really. So if you can get yourself a vise, and they can be also got pretty cheap, I think that was about 50 bucks for that sort of thing, then you would just have to work out a way that you're going to be able to implement that onto a table. You really do need to have some sort of work table, some type of table, even if it's something like this old Ryobi router table that I've had lying around for years. I mean, you can buy them pretty You it's a metal top, so you can weld on that without any dramas. You you need some sort of table to work on. Working on the floor all the time really sucks balls because it's tiring having to kneel down on the ground all the time. In saying that, I am an old fart and I have done a lot of that, and so I'm a little bit less tolerant to having to work on the floor these days. So I tend to do everything up on a table. But you guys all being spring chickens, you can just work on the floor if you need to, okay? But if you can get a vise and into your tool mix, you will thank me forever after purchasing one and using one. So get yourself a vise to make your life easier. You're going to need a welding helmet, otherwise you are going to go blind. So here's a range of welding helmets that I use. This is your basic pop down, pop up, so that requires 2 hands. Okay, perfectly fine. It is handy though to have an auto shade welding helmet because then you've got 2 free hands the whole time. They can be had for about $69. I would recommend auto shade. It makes your life a lot easier. But regardless, whether you get manual or auto, you are going to need a welding helmet. I recommend an auto shade welding helmet. Get yourself a welding helmet. You're going to need a welder, guys. I use predominantly a MIG welder for this sort of application because the metal that I'm using is all well and truly light enough to be welded with the MIG. If you don't want to spend the money on a MIG, and let me just tell you that if you buy a MIG, it will be a lot easier for you to weld with a MIG. And you don't need to buy gas. You can buy gasless MIG wire now. It does a perfectly good job. That's all I use. You go through some of your consumables a bit faster with the gasless MIG wire, as in your tips and stuff like that, but they're cheap. A packet of these 0.8mm tips, right, they're like about $6 for 10 of them, right? They're cheap. So I would recommend a MIG welder, and I've seen them as cheap as $129 for a MIG welder, okay? If you don't want to spend that much and you would rather use a stick welder, and you can use a stick welder for doing this, it's going to be probably slower. You're probably going to burn more metal with this until you learn how to use it. But this little stick welder that I bought, right, it's got heaps of power. That's what I built my big press here with, which is like all 8mm steel, because you need penetration when you're using really heavy steels. So I always use a stick welder on heavy steel, but it can be used for light steel. You just got to wind the power back, but it is harder to use. The more your power is wound back, the harder it is to get it to arc. Though these new inverter chip welders, they do weld really well, you know, much easier than the old days when, you know, the old big transformer welders that I started using when I was a kid. You know, they were really hard to get them started, hard to keep them going. These are just like so much easier. So you could use a stick welder if you wanted to, and this was $100 on eBay. It's a Rossi, and I've used this so much. It's been dropped, all sorts of stuff with this, and it just keeps on going. So if you don't want to spend as much on a MIG welder, you can buy a stick welder. You just need to buy smaller electrodes to do the lighter metal, but I would recommend a MIG welder. It's less fiddling around. You don't have to change out electrodes all the time so quickly. This particular one I've got takes a big 5 kilo wire roll. You don't have to get that. You can just get them that take the little 2 kilo, 1 kilo wire. That'll be enough for you to get the job done. You'll need a few little things to go with your welder, like we've already talked about, helmets and gloves. You'll need some consumables if you buy either. You'll need electrodes. I'd get 2mm and 1.6mm electrodes, just mild steel electrodes. If you're going to buy a stick welder, just get 0.8mm MIG wire. If you buy a MIG, get a gasless MIG wire. Buy yourself some 0.8mm welding tips for your MIG. Get yourself a slag hammer, okay? Just one of these is perfectly fine for chipping the slag, and get yourself a good wire brush. Either a hand brush, or you'll use brushes that I've already sort of pointed out on a drill. They'll all do very well for getting rid of the slag. Got to get rid of that slag. That's what corrodes and that's what compromises your welds. So you will need a MIG welder or a cheap stick welder. Get yourself one of those, whichever one it is. That's up to you. Talked about this briefly in our other videos, but I want to be specific. Get yourself some 100mm in diameter bearing insert casters for your rear traction loss setup. You're going to need those. These were from Bunnings. These are called Move It, I think is the brand they're called. Move It. make sure they're a bearing insert, make sure they're 100 millimeters in diameter. Now these were swivel casters, okay, that I've welded offset, so they're not at a straight 90-degree angle, so they're offset so then they don't bind when the traction loss moves in its range of motion through its arc, so there's no binding. So don't panic, I'll show you how to weld them rigid. It's a bit messy because you've got bloody grease in the bearings, but you just got to put up with that. That's an easy workaround. You just let them cool down in one position and the grease doesn't go everywhere. So you will need 100 millimeter bearing insert, polyurethane wheel, okay, is the best one to get. You'll need to get 2 of those. That concludes part 3 of the 3 Degree of Freedom DIY step-by-step motion platform simulator build. Sorry that it's been a little bit boring, guys. I know we're just talking about tools and materials, but without those items, how are you going to do this build? Really simple as that. Thanks so much for tuning in. Thank you very much for subscribing. I'm enjoying helping you guys out. I'm appreciating the fact that you're helping me out by subscribing. Thumbs up to you guys. And I really look forward to getting down and dirty in the next video where we start putting this motion simulator rig together. Feel free to hit that bell for notifications, so then you get a notification when that video is released. And you don't just have to keep coming back here in the hope that it is. You'll get a notification. Sounds pretty smart to me. Anyway, catch us in the next video, guys. Peace out.